All right. So today we're gonna spend some time to talk about disk and washer, and then we're gonna do demonstration. I'm pretty sure you already hear it from your friends. Good. Joshua, not your friend. Disk and washer, not dishing washer. Yeah, that's why Safa thought the whole time. She's like, dishing washer. Okay. And dryer. All right, so we have a disk method to find volumes, or versus washer method. Now, disk is like a circular disk. For example, my this lid is a circular disk. So imagine that if I have this cup, if I want to find the volume of the shape, it's not exactly cylinder. The bottom is smaller, the top is bigger. So basically, I'm adding each different type of cylinder from top and bottom. So depending on how the height of the water, the radius is different throughout the whole time. It's constantly changing from the bottom to the top. Okay, so that is the way to think about things. Okay. So this method and the washer method. So let's start with disk. Also, I'm going to talk about different type of rotations. Okay, so there are different type of rotation. Usually, in general, the easiest one is rotate around x-axis. X-axis. And 2, and be rotating around y-axis. 3, you'll be rotating around off-axis. So it's not x or y. It's any other place besides x and y. Usually it's a straight line. I'm not going to give you a diagonal line rotation. That would be way too hard. So it's going to be a straight line or horizontal line. And it's off axis though. It's not on the x-axis or y-axis. So there are different type of things. In the past, in geometry, we can find the volume. If I want to find a volume basketball, 4/3 pi r cube. Cube. 4/3 pi r cube. That's a volume of sphere, right? So volume, let's say basketball. Basketball. Length is equal to volume of a sphere. That's equal to a 4/3 pi r cubed. Most of you guys don't remember unrelated rate. Remember that? 4/3 pi r cubed derivative is surface area, which is 4 pi r squared. Now here's the thing. It's all the time that we're gonna get a shapes that is manageable by geometric formulas. Well, the truth is, think about a different thing. Think about football. Right? Football. Do they have a geometric shape in geometry that tell you how to find a volume of football? Well, not like I know. I taught geometry like, I don't know, 15 years ago. So how about a base? Like a base, right? I don't know how to draw a base. Sorry. A ball. A boss. So a base, right? How do I find the volume of that shape, right? How do I find a volume of this? This one's not too bad. I can figure out using the average of the radius and just draw a like uniform, like an average of two radius. So it's gonna be, if radius is 5 here, radius is 10, so radius in the middle is probably like 7.5. And I use 7.5 to average. So using the idea of isosceles trapezoid to find the cylinder of this, which is not too bad. But yeah, you have football. So the idea is, hey, how do I find the value of football? Well, a football has a is interesting, right? So what I propose is we propose a function that is really close, look like a curvature of a football. What will be a function I can think of look like curvature of football? Well, I hear something. Somebody says square root of x. Square root of x. Y square. I'm gonna show you. So I'm gonna also have a cutoff line says x equal to 4, y equal to 0. So I have those three boundaries, right? So what I'm gonna go with here. So I'm gonna plug in 0, 0. If you have problem graphing, I would just plug in viewpoint. See what happened. And this is a 1, 1. And this is 2, 4, 4. 4 is right here, I think. Hold on a second. No, it's the other way. 4 is right here. No, right first. 4 here. So that's gonna be 2. So it's gonna be like this. If I plug in, does it look like a curvature of a football? At least a quarter of it. Four, right? And so the curvature of football right here, and here, and going through this point. So it's gonna be like something like this. So that looks like a kind of like a football, right? And it is also cut off here. So it's like this. Now, how do I make a volume of a football? Multiply by 4, but that's just going to give you area of a cross section. Does not give you a volume. Okay, so Fiona was right. So Fiona says, hey, what if I take this graph and rotate around x-axis? So what happens when they rotate? It's gonna create something like this, and like this, and like this, like this, and it's rotating. What I mean by is this graph is gonna rotate outside the board and go toward the inside the board. It's gonna have that rotation. And then I will probably get a volume of football.
Why is it a thing?
So I'm rotating. So I'm gonna have this notation. Okay, this notation is called rotation. So this is the rotation symbol. So it's gonna look like this. So it's rotating. So the graph, actually this part should be dotted line. So it's gonna be like dotted because it's not real. It's rotating around that. So it's gonna be dotted. And that's going to be a volume of football. How many of you guys can visualize this or no? Who cannot visualize? Raise your hand. Yeah, visualize the spinning inside and outside the board.
It'd be like a Z.
Okay, so what I'm going to do is I'm going to help you visualizing and help you different things. My thing is always create situations where you have visual, because a lot of time is about visuals. So what I'm gonna do is I'm gonna have a chopstick as a drill.
Wait, no, do I remember this? No, it's just because it's not like actually. Yeah. That's like yeah.
Okay, so
Oh, it's watermelon.
yeah.
Sorry.
I have also heard stories.
Balin, duck down, please.
So so we're gonna show you this watermelon. Okay, so this watermelon is, if I keep on cutting inside, the radius of watermelon is getting bigger or smaller. Smaller, but it's each one is a disc. It's a disc. So I want to show you that disc, and I want to show you in the actual live demonstration. So here is the watermelon. You're gonna see a disc, and disc gonna go toward inside. Everybody can see that, right? So, where's my knife? Grab it.
Probably not. Don't give it to me.
All right. If you fail your AP exam, I'm just saying.
Yeah, you said that you're gonna cut the radius and like, what was the?
So what we're gonna do is, so if I cut it this way, I'm gonna form different type of radius, right? So a radius is getting smaller all the way to here, and you're gonna see that. So basically, we're just gonna adding all the different type of disc, because if I cut an infinite amount of slices, I'm gonna see a green part outside and a red part inside, and it's gonna reduce down to a little bit, down to tiny pieces. So what integral do is just basically adding up all this infinite amount of disk, and then you can find a value in this. So what I'm gonna do is I'm just gonna cut one slice that represent that functional graph. So I'm gonna do that in a second. So hopefully I don't cut my finger off, because I only have one eye. I don't want to have it 9 fingers.
I thought you were gonna say that.
Oh, good.
Don't worry, I already done this 3 period already, so I know what the hell I'm doing. What? What'd you say?
Did you buy like?
Yeah,
I thought you were gonna cut it like.
Can we eat it after?
you sure can. Yeah.
Let's kind of like.
So,
Sure.
sure.
It's like lukewarm.
You should have your fingers like this.
It's like sour.
Okay, so so what I'm gonna do is I'm gonna cut a slice of watermelon just resemblance to that graph. So I'm gonna see that if I can do that.
You need help.
No, I'm fine.
I'm so scared of it.
I don't think it's sharp enough.
I do know how to cut watermelon. Okay, so this is equate to, hold on a second, let me go up here. This is equate to this, right? Well, it's kind of big, but you see the idea, right? It's rotating like this, right? In order to help you visualize the rotation, so come up a way to drill the watermelon.
Can you duck again?
What?
Appreciate it.
If I know how to use the drill. Okay, so what happened is I'm gonna drill this part. Hopefully it will work. Okay, it does work. Okay, good. Make it a little bigger. So what I'm gonna do is I'm gonna help you see the rotations. What?
Is that a...
This is a chopstick.
No, it's not.
Yeah. I don't think it's the chopstick.
This is a really huge ass chopstick. Okay, so now,
You know, better way.
Is that what he made it green and red?
yes.
Oh my
Oh,
god.
wow. So that's gonna be rotating like this. So if you see that disc, okay, you see that disc, right? So it's rotating around here.
Spinning around.
Okay. So it's rotating like this, right? Now this disc is getting smaller and smaller. So first of all, this is the functions, right? So we take this. Just imagine that if I just cut one slice here, it's rotating. If I rotating that slice, it's gonna be a disc. Now I'm using integral to add an infinite amount of discs. So that's why they call it disc method to find a volume of a shapes that usually is not in geometry.
Oh, so you take the area under the curve.
You rotate it. You're not area in the curve. You just take one slice. So you basically take one slice of watermelon from here to here. Let's just imagine this finger. And if I just cut this part off the finger, then I rotate. If I rotate, it's gonna form a disc of watermelon. And we are adding infinite amount of discs because the radius changing. The radius is constantly changing here. So we are adding from actually 4 to all the way to 0. The radius is changing from, let's say, 2 to 0. So with that being said, hopefully it help you see visualization. But sometimes I think my favorite teacher physics, he teaches at MIT. His name is Dr. Lewin. He's one of the best professor in the world that in the past, but he's no longer a teacher. No, I drill on it, so there's rust on it, so I don't think you want to eat rust.
That's the class name. Why did you have to use watermelon? Not like another.
Watermelon's so much cooler. Huh?
I love watermelon.
I know, me too. It's much funner to draw into watermelon than anything else. So,
Do you have another chopstick?
what's my apple pencil? Huh?
Do you have another chopstick?
I might. I don't know.
Don't see how to use it.
This is a chopstick to cook, so it's longer. So you cook, it's longer. So the regular chopstick is about this thing. The cook chopstick is about this thing. So we like cooking stuff to it. So hopefully this demonstration helped. But if it doesn't, at least I tried. So I am gonna go back to actually things like you like the transition chat? Okay. So now we know that the rotation. So the idea is we're gonna base the idea of disk. And the disk is we can find geometric shape of a disk. So area. So area, oops, my bad. Area is equal to pi r squared because that's a disk. So that's a disk of like a circular disk like this, right? And we can figure out that. Then, so what we're gonna do is there was infinite amount of disk between here and here and here and here and here, and of course it gets smaller and smaller. Each disk is smaller and smaller. I didn't draw it perfectly, but you get a point. Let me see if I can draw it better. So that's just gonna be like this. It's like this, like this, like this. So each disk are different. What integration do is just adding up all the disk, which is nice. So what we're gonna do is we come up with this method. We're using the same idea. We're gonna say, hey, let's find out the volume of this method. So is any general formula for this method? Well, we know it starts from area equal to pi r squared. But we want a value. we want a volume. So the only thing that deal with volume is actually it's going to be volume equal to pi integration from a to b of r of x dx squared. R represents the radius, and radius sometimes can be represented by some function that we know of. In this case, we happen to know the function because in this case, what is a radius function? What is represents same as a radius in terms of this situation?
Like height.
Not 4.
0 to 0 to
Yeah, but it's changing. The radius is constantly changing. Depends on what the x value is. The radius is changing.
Is that radius squared?
Okay, what Bennett says, hey, can I just say this r of x is equal to square root x? Well, think about it, see if it's true. Imagine it's at 1, right? What happened at 1? I plug in square root 1. My radius is 1 units. Does that make sense? My radius here is 1 units, right? Imagine if I plug in at 4. Square root of 4 is what? 2. My radius is 2, right? And anything between is going to be square root of whatever number is. So in this case, can I say it's r of x equal to square root of x? Because that's a radius. So then you say, okay, well, in terms of this situation, b is equal to pi between a to b square root x. It's not all the time the square root x because sometimes we might use different function. We might use x cubed. Sometimes we might use y squared. But in this case, it's going to be square dx. What is a and b in this case? 0 to 4 because that's the x value, right? So in this case, it will be 0 to 4. And you're like, oh, okay, that's pretty easy. We know how to do integral of this. So the square root of x squared is just going to be x 0 to 4 dx. And that's going to be x2 over 2 between 4 to 0 pi. And that's equal to a pi. But a pi is only half of a football. If I want to find a whole football, it's probably 16 pi. If our units is inches, we can say that's 16 pi inches square for that situation. But this has to be correlated. The scale has to be the same. So yeah, that's how I find a football using a formula that looks like square root of x, that looks like curvature of the football, and we can rotate around x-axis and we can find a value of that. Now, with that being said, we're going to go to this method. We're going to come up with general formula. So I know we already did, but we're going to try it again. This method, general formula is going to be between a to b, a pi of r squared x dx. Now, however, we do have a different orientation. Okay? What if sometimes I'm rotating, like if this method rotating around y-axis? Yeah, you can have in terms of y. So that's going to be pi c to d. Why c to d? Because the boundaries switch. Jesus, pay attention. Write on your own paper, not on her paper. R squared of y dy. So I can have a radius going this way instead of this way. Okay, I have radius going this way. So because my rotation is different, so I have to pay attention on vertical cross section, right? Vertical cross section, and this is a horizontal cross section. Horizontal cross section. So that's this method. But we only cover one of the method, not both. What is the second method? Washer. Well, first of all, you have to know what's a washer. Sabadao is like dishwasher. Or like dishwasher, like, you know. But it's not a washing machine. The washer is like in toolbox, you have washer to stabilize the screw and to draw in to balance the, to fixate the screw much better. So the washer looks like this. The ring. It looks like a kind of like a ring. There's inner ring and there's outer ring.
So wait, should we run this?
Yeah, we're gonna follow washer. Now we're gonna deal with washer. So washer is gonna be like this. So and you say, okay, that's just a washer. That's the thing that you can put a screw in there and you can like. I guess the purpose is to like stabilize it. I have no idea what is useful. I'm not handy enough to tell you what happened. So now here's the thing. A lot of times like people don't understand how to find the area of this shader region. So this shader region, that is something I'm paying attention to, is this shader region, which is there is a bigger radius from here to here. So this is, we're gonna call it big R. And there is small radius here, we're gonna call it small r. Okay, so I'm gonna give you two choices, and hopefully you guys all pick the right choices. So I'm gonna give you two options to find the area of the red part, red shaded region. So the first choice I'm gonna give it to you is pi r minus r squared. The second choice I'm gonna give you pi r squared minus r squared. First of all, are they the same or are they different? Think about that. Second of all, which one is a correct way to evaluate the red ring, the area of the red ring? Okay, with knowing the bigger radius is R and small radius is non-capital R. So what do you think? The first one or the second one? Think about it before you say it though. Think process through everything and think about, you know, it's gonna be the first one or the second one, or are they the same?
Are we finding bigger or smaller?
We are finding the area of the red ring. The shaded part, yes. Not the middle part. What do you think? The second one, okay. Let's ask Aspen. What do you think? The first one or second one? Second one, okay. Let's ask Alan. The first one or second one? Second one. Nizar. Second one. Jenny. First one or second one? Liam.
Would be two.
Did anybody say the first one?
Wouldn't two?
Anybody say the first one? Oh, Gabby? Okay. Anybody else like Gabby? Okay, so Gabby says is the first one. I like what she does because she that's what she thinks, and that's what we need to understand. It's okay to come up with a different view. But here we're going to show you that the area of a shader region is the bigger square, a bigger circle, which is the whole thing, minus the small one. Is she gonna make it back or no? No? Okay.
For you. Heat it up, because Ye wants her back.
I don't think he saw that. Why not?
Wouldn't it be better if the demonstration be like cut?
Yeah, it would. It would. I just don't have time to do it, but I would.
What's your opinion on pineapple?
It's good. I love pasta. Oh,
We
bring
have
it
like
in.
50 that are growing in our backyard right now, and they're all gonna be right at the same time. No way it's gonna eat them all by ourselves.
Okay, give it to me. I love pineapples. So now with that being said, right? It's not the first one, but that's okay. But imagine this, right, Gabby? Now imagine that if this big radius is 5 and small radius is 3, right? If I have 5 minus 3, then that'd be 2. So that you actually find the area of the inner ring, well, not exactly inner ring, but it's a little bit closer to the inner ring than the outer ring. Because you look at the difference first, and if you subtract the difference, that becomes the small radius, and you just basically find the area of that small radius. Does that make sense?
Yeah.
So what you need to do is take the big area, subtract the small area, and those two are not the same because they don't distribute it. You kill a kitten if you do that. So this is the wrong way to approach it. This is the correct way to approach it. And we don't worry about this. So this is the best way to approach it. So we're gonna use a washer. Now you're gonna be like, wait, why is a washer that involved with this? Now I have another demonstration with visually.
What is that? The Death Star? It looks like Earth got hit by the Death Star. That's what that looks like.
Okay, so Solar Revolution. Oh, not this one. It's this one. Okay. So imagine this graph in a correct orientation. This is square root x graph, and this is rotating. You see the disk, right? Okay, you guys see that? That's great. But what if I change? Oops, my bad. What I just did. What if I change this to, let's say it's 1/2 x? So I have an inner radius now. So 1/2 of x here. Okay, so now I have this. You're like, oh, what does that look like? Well, first of all, if I have 1/2 x, the view of this way is going to be like this. And without rotation, it's probably like this. Okay, so now we're rotating this small pieces. We're rotating this. Now there is there's inner radius and there's outer radius. And for you, it's probably hard to see this because even I turn this to the sideway, and if I turn the sideway and I just rotate it, it's gonna look like this. But then if you look at this view, you're gonna say like, oh, okay, that's just a ring. It doesn't look like washer to me. Now what if I change this to 3? If I change this to 3, wait, how do I change this to 3? Oh, change it. So that just changed to 3, then you can see it better. Well, 2.8, that's fine. That's good enough. So if I do it here, do you see the ring? That inner ring and outer ring, because that second ring is the carved out. The second ring is carved out. Imagine if I take this, right, and I chop this part off. Like if I just cut it off, if I just shave it, then if I cut off this. So let's see if I can do that.
Yes, it has to be circular.
It doesn't matter. I can. So that's just like this. Now I rotate. Right? So if I rotate, I have an inside carve out. And if I rotate this, it's gonna form a cylinder. Cone, sorry. If I rotate this, it's gonna be a cone. Because if I rotate this, it's gonna be a cone.
You put on the drill. Eat it.
No, it's gonna be
No,
like
I'm not. Okay, so so now we have a ring. In that ring, we had accumulated all the rings that together. So in this case, that we have a big R and small r. So for this particular case, that washer is going to be composed of A to B, a big R of x minus small r of x dx. And this is going to be a square, and don't forget the pi. So this is the washer method. A washer method, and then also between C to D, I can do it different type of orientation, and it's going to be in terms of function of y and dy. And this is pi. So you can have this two situation happen as well if you have washer. Yes.
In terms of Y, like what would that look like? Like we do anything in terms of X with the R and stuff, so
Yeah, okay, I'm glad you asked that, but so there is a different rotation. This is a Y rotation. So this is a type of rotation, so that's 0 to 4. Let's do 0 to 2. 0 to 2. So now this is y equal to x minus 2. So it's basically a parabola shaping right in the first quadrant. It's rotating. So it's going to look like this. So remember, this is a y equal to this, and it's rotating, so it becomes a spin top.
Dreidel.
A dreidel? Yeah, you can say a dreidel. That you can
A witch.
That is
Like a witch. What if pretending it was
a witch hat. Yeah, you can think about witch hat. So yeah, that's gonna be rotating along y-axis. Did that help you?
yeah, thank you.
You
Ah.
you said it equal to 2.
What equal to 2?
And
And equal to 2. It just rotate another rotation. So I'd probably show up as different color. Okay, so any question about this part? Now this is also a idea of disk, but it's not a washer. So now, so I have teaching this topic for 12 years, and every year I try to have a student learn it, and instead of takes like 5 days to teach it, I'm trying to reduce down to 3 days. Try to reduce. This is the first time I'm trying to reducing 1 day, a block period, so which is 2 periods. So so for the last 10 years, I'm trying to come up a systematic way, an idiot-proof way. Anybody can do it, where it should not mess up. If you mess up, then you're an idiot. No, I'm just kidding. I'm an idiot. Because I'm trying to form an idiot-proof way where everybody can do it. But you guys have to try it though, because if you guys try it, then you'll see. Okay, this is actually working. The problem is off-axis questions. That's a lot of students. Now, here's the most of the thing is drawing. It's going to be based on drawing, and recognize what you're drawing is very, very key part. So you do have some very good drawing skill. So what we're gonna do is we come up with 7 different steps to help you solve the problem. There's 8 things, but 8th thing is just notify something, understand something. So there's total 8 things that you have to go through. If you go through this 8th thing, you should get an answer pretty easily. So this is Mr. Ye EDS proof way to find the volume, even with this washer and this shell and oh, also there's a shell method and this cross section we're gonna deal with Monday. So here's the thing. The first step I would say draw the bounded graph. Everybody, we already did that. We did that with the football shapes. Draw the bounded graph. Second, draw the notation of axis rotation. And what I mean by that is this notation right here. This notation right here. This is rotating right here. Sometimes you can rotate right here. Sometimes you can rotate right here. So that axis rotation, you have to label the axis notation because everything's gonna base off on there. Everything's gonna base off of axis rotation because the third step is a very crucial step. The third step is draw a line or lines. Okay, line or lines. So sometimes maybe one line or two lines. It has to be from a certain orientation, okay? Has to be from axis of rotation to the boundaries. So to the boundaries. So sometimes boundary, sometimes boundary. So if you hit one bound, then it's going to be a disk. If you hit 2 bound, it's going to be a washer. So I'm going to explain that. So if you hit if the line, if it's one line, if it's one line, then it's gonna be a disk. If it's a two line, when you hit a boundary, you might sometimes hit it twice, so it's gonna be a washer. Okay, so if you hit one line, it's gonna be a disk. If you washer, it's gonna be two line. For example, I'm gonna show you that this here, a basic one, just say if I have from here to here, if I draw one line here, so start from axis rotation, it had to start from the axis rotation. You cannot be the other way. You cannot be this way. This is bad. It has to be this way. From axis rotation to the graph. So see that I only hit one line, right? If I hit one line, it's a disk. Because this is disk. Now if I'm rotating around y-axis, might be different. If I'm rotating around y-axis, I'm hitting how many lines? 1 and then 2. So if you see 2, that's a washer. So this example of washer, and this is example of a disk. So because you hit 2 lines, it's going to be a washer because you had to worry about a carve out. So that's something that you have to worry about later. So step 4. Step 4 is decide dx or dy. Dx and dy is very important because if you have a dx, then your function should be in terms of x. You should evaluate everything in terms of x. It'd be y equal to x squared plus 4. X squared plus 4 is your function. Does that make sense? If it's in x. If it's a y, then you have to be y minus 4, square root of y minus 4. Because it has to be in terms of y. So you have to know which type of function. You have to know, are they dx, dy? How do I know dx? Well, dx if the cross section is vertical. So if you have vertical line, when I draw a line, it's vertical, that is a dx. And this is a horizontal. Horizontal. So dx is going to be vertical, dy is horizontal. Fifth, decide a boundary. Now the boundary could be A to B, right? If it's in terms of x, right? If C to D is going to be in terms of y. Does that make sense? Because sometimes you can calculate area from 0 to 4, sometimes 0 to 2. If it's y, then 0 to 2. If it's x, 0 to 4. Depends on that square root part. So you have to understand that the boundary can change, depends on the situation. Depends on your dx. Dx then is going to look at x bound. Y is going to be y bound. Now, Leo, you okay? You sick? Okay. I'm almost there. We're gonna get to actually trying the problem. I know it's really a lot of work, a lot of things, especially you already go through 2 block period already. Question 6 is you decide a boundary. You also need to decide, are they disk? If it's disk, you have to decide what is r of x or what is r of y. So you have to figure out what they are. So what is the function represent the r? If it's a washer, then you have to decide what is r of x and r of x. Or r of y and r of y. So you have to decide 2 things if it's a washer. So washer is slightly harder because you have to find out 2 different functions. But they are based on drawing. So if you base on drawing, it'll be good. 7 is people usually forget certain things. So I don't want you to forget certain things. On AP exam, they take points off each thing you forget. So don't forget certain things. So don't forget pi outside. Because of pi r squared, the pi is very important. Without a pi, your answer is wrong. Don't forget the boundaries, which is from 1 to 4, 0 to 5, whatever. Don't forget the dx and dy, dx or dy. Lastly, don't forget the square. and parentheses. Parentheses is, so don't forget those things. Just just to kind of double check you didn't forget everything. At the end, double check, do you forget pi? Do you forget a square? Do you forget a dx, dy? Do you forget a boundary? Do you forget a parenthesis? Parentheses is very important. So this is the basic 7-step, but the last one here is very crucial here. So this one, I'm gonna put like 3-star mark here, is for you to understand. If I ever have y equal to some type of things, or f of x equal to some type of thing, that thing is represents the distance from x-axis to the functions. It's a distance. So if you have y equal to, let's say, it's 2x plus 5. The 2x plus 5 is the distance from the x-axis to the function. Or it can be rewritten in this way. If you have x equal to whatever, or f of y equal to whatever, this whatever represents the distance from y-axis to the function. I'll give you an example. So for example, we have square root x. Square root x here. This is square root x, right? Remember, from here to this point, it's going to be y equal to square root x. That is the distance from the x-axis to the function. Now the distance from here to here is x equal to y squared. That's the distance from this point to the function. And so that is able to help you generalize everything. Okay, so now we're gonna try questions. We have good 50 minutes to try different questions. Okay. So make sure you follow those things, and then we're gonna start with that thing. So first thing is I want to give you a graph. Same thing, we not give you something crazy. Y equal to square root x. However, the x equal to 3, not x equal to 4. Not like last time, it's x equal to 4. It's x equal to 3 this time. And y equal to 0. So I want you to draw this bounded graph. First thing, if you need to plug in a couple points, you need to figure out. First thing I want you to do is rotate around x-axis. I want you to find the value of this particular shape is rotating around x-axis. The only thing I change is from 4 to 3. You're gonna draw y equal to square root x, x equal to 3, y equal to 0. You're gonna draw this bounded graph first. And you have to find all this information. The second things I want you to rotate around y-axis. C. I want you to rotate around x equal to 3. D. I want you to rotate around x equal to 6. Yeah, so we're gonna start with those 4. We're gonna give you 4 more, but we're gonna start with those 4. Okay, so let's figure out the first one. How do I find the value of this particular shape rotated around x-axis? This first one should be easy. It's very close to the last example we did, but slightly different. guys finish or no? We're gonna start by drawing the graph. We follow the first step. We plug in some points. We're gonna stop at 3. So this 2, 3. We stop at 3 and we stop right here. Did you guys do that? Did you do this notations? There. Within 0 to 3, I'm gonna draw from axis rotation. It's not from the boundary to the axis rotation, from the axis rotation to the boundary. This is very, very important. It's going to be like this. Do you draw this way, the arrow facing up or facing down? You don't want to have arrow facing down because that doesn't make sense, because your rotation is based on start with that dot to the arrow. You take that arrow, you rotate. You rotate from that arrow, you're going to get a black disc. Because that's a black line, you rotate it completely, it's going to be a black disc.
Why do you have that arrow? Because it's just the washer disc.
Yeah, so it's also this only one line is it has to be either disc or washer. So now I'm gonna start with depending on which boundary. You hit one boundary, it's gonna be a washer. You hit one boundary is disc and 2 boundaries washer. So is this dx or dy? Dx because it's a vertical line, so I'm write down dx. So I'm write down small information to help me to solve problem. What a boundary from where to where? 0 to 3. Okay, good. So we have did that. This is the disc washer. Disc. So by adding those stuff, so I'm gonna figure out what is r of x here. What is r of x? Square root of x. So it's gonna be square root of x squared dx between 0 to 3 pi, and that's how I set up, and that's how I get my evaluation of answers. Okay, let's do the next one. This one's a little bit challenging. It's rotate around y-axis. How do I rotate around y-axis? You're gonna follow this folding again. Everything slightly changed this time, slightly. And you have to figure out what makes changes. Yes?
So it's like this now, right?
It's gonna be like this. It's like
McKenna, can you speak louder? I cannot hear over this.
Because the boundaries from 0 to 3, would we be able to rotate on the y-axis? Because it could be going to the negatives. And it doesn't make a difference, right?
No, the boundary is different in this case. It's
Okay.
rotating around y-axis is different. The way you stop, when you stop integral is that matter.
Okay.
So you want to think about where the y stop. Never seen you so tired before.
it's gonna look like this.
Huh? You had it? McKenna, what'd you do to Nelly?
I did Nelly.
She says it's your fault.
We had a rough game. We were on the phone a little late last night.
She seems okay.
She was sleeping last period.
Okay.
Survived that period, and I'm surviving this one.
Yeah, it seems like today is not a good day for you.
You have to solve maybe with
You don't have to solve, you just set up right now. Now are you done? Okay, so let's talk about the shape. Before you evaluating, can you tell me what the shape look like? Very sharp bowl.
It's like an inverse one. With a point.
Yeah.
It's like a pointy bottom. Yeah. I've never had a one.
Like the cross section, like a plum.
Flat bottom. And it's like
Like a it's not like it'd be like this. You know? Like those old fashioned pillows with the button in the middle, like
Like a little button and then
Oh, I kind of see that. But they usually square, so.
yeah.
but there's the ones like those pillow ones, but like
Yeah.
So, think of a cake,
What? A bun cake?
a bun cake. It kind of like.
It's like the opposite.
what the hell is a bun?
A bun cake. Okay, so how to spell bun cake?
It's like a bun cake. It's like a the middle.
B-U-N-D-T cake.
Milling bun cakes is really good.
Right?
They're good.
You're the second person to tell me that.
I never
I never tried it before.
Oh, they're too expensive. Don't buy them. Oh. I have like a
It doesn't have a hole, right? It doesn't have a hole.
I have like a hyper rich neighbor that gets them often.
Such a nothing bun cake.
to really put a little bit in.
I think waffles are closer to brownies than cakes. To be honest. What if I
All right, so so we're gonna follow the steps that I propose. So I'm gonna start by drawing, and I'm gonna drawing this graph. I'm gonna stop at here, and this is the graph. Now I'm gonna draw the axis rotation, so I'm gonna draw axis rotation. I guess I can use that, the vertical one like this. Except what's the function? Square root x. So square root x like this. And to 4.
Isn't it 3?
So it's gonna look like this. Okay, so it's looking like this. I don't know if it is a good orientation, but yeah, you get the point. Okay, does that make sense? So it's gonna outside it's a cylindrical, inside it's a carbon, but I don't think it did a good job there. So so I'm gonna draw this. So now between those two values, I'm gonna draw whether to hit one boundary or two boundaries. So if I go in like here, so going from here to here, sorry, let me use different color. I don't like that color. So I'm going from here to here, that's the first boundary. And there's a second boundary from here to here. Do you see that? So there's two bounds. There's red and green. So is it dx or dy? This is dy, good. So that means function has to be in term y, yes.
How do you know how many bounds, like, is it regardless of what?
You okay?
Yeah.
Okay. What is that meeting about?
Getting expelled. It was like my dad. Yeah, getting
What did you do? Is everything okay though?
Yeah.
I'm not in trouble, right? That's the only thing matters. Can we take a picture together? Don't get in trouble. All right, so I'm glad you make it back. All right. So we have draw two lines. If it's two lines, it has to be a washer. So I'm gonna write down washer. So everything I do, I write it down. Kind of told myself it's washer. And what's a boundary though? What's a boundary? So we're gonna say dy. What is a boundary? 0 to root 3 or 0 to 3? 0 to root 3. Why? Because you had to plug in this 3 into here because we want to know the output of here, which is root 3. So 0 to root 3. Do you understand why 0 to root 3? Because we stop integral at this point. We stop integral at that point. At that point, it's going to be root 3. And we also know it's washer because we see there's a 2 line, and that 2 line we need to figure out what they are. So we're going to write down what is R of y and R of y here. What is the big R of y and what is small r of y here? Hayden?
Big R of y is square root 3 and little r of y is 0.
No. Okay, so that's good try. Connor, what about you? McKenna? Nope. It's constantly changing, so a lot of things, some things stay the same, some things doesn't. Bennett, no, I'm not called Bennett because Bennett is very intuitive for geometrically.
Is the big one blue?
So I don't want it like I want people don't know to share with their ideas. So let's start with Alan. What do you think?
Square root 3 and square root x.
Nope. Katie?
Big will be half.
Nope. Jenny? Nope. What would be the big R? Big R represented by the red line, and small r represented by the green line.
What's the red line there? Like the non.
Red line's from here to here. Remember, it's from here all the way here.
The big one is
Hayden.
The big R is normal 3 and little r is 0.
One of them's right, one's wrong. I'm not telling you which one's right, which one's wrong. Shh. Neither. Neither.
Big one is 3.
Small one's what?
Great question. It has to be very small. Oh wait, maybe it's not. No, it has to be less. Kind of like 0.8 or something like that.
Liam?
Is it 3 and then root 3?
What?
3 and then root 3?
No, but no. Misha. 3 and y squared. Good job.
It's a big.
Well, why is 3 though? Look at here. From here to here, it's always 3. It doesn't matter how I draw it. The radius, the outside cylindrical is always 3. So the big R is actually always 3. So that's 3. And the small r is what's changing. But remember, we talk about this. The distance from here to here is what? Look at here. What we write down? The x equal to, or fy equal to, is the distance from y-axis to the function. Distance, so this is a what? This is a x equal to y squared, right? X equal to y squared is the distance from y-axis to the function. Got it? So that's equal to y squared. So therefore, it's integration from 0 to root 3. Don't forget pi. I already told you. If you forget pi, AP exam will take your points. 3 minus y squared, and then parenthesis, don't forget squares, because it matters. And that's it, you're done. So we find a volume of a bun cake. You're gonna do one more. You're gonna do a few more. Sorry, not one more. You're gonna do at least 5 more. So rotate around x equal to 3. I want you to rotate around x equal to 3, but you must write down those 7 steps. If you're not, you miss those 7 steps. You can take a picture if you want.
Oh. It's kind of like a Y axis. Like, what would the final shape look like? It's like this.
Why?
That's okay. Sorry, I don't know how to explain it, dude. It's like a tooth.
The big R is the entire thing.
We know it's like this. big R is from here. That's like a cave boundary. It's like a slate. Big R is from y-axis to the end of the boundary. And then little r is from y.
Okay, we're rotating around x equal to 3. Try all 7 steps. But this one, I believe only one student can get it right in here. Maybe 2. Oh, maybe 3.
When you do your lines, does it always have to be from
For an axis rotation. You draw a dot from there and draw whatever to the edge. I believe only 1 to 3 student can get this one. Oh, I forgot about Bennett. Bennett might be able to do it too. Bennett's really underrated.
That's an easy one. Yeah. I knew that.
Its vertical line is dx, its horizontal line is dy.
Pretty good. It's gonna look like a nose.
Ruby Washington.
It's gonna look like a cone. Yeah. So like that point. Yeah. Like a flat cone.
It's like, you know, there's like a Thomas.
It's like a semicone. Plunger.
Punter?
Like a toilet, but like without the stick.
I guess you can say that.
Yeah. Exactly. Yeah.
Like dome.
The rubber plug.
It's a dome.
I don't know.
It doesn't have a hole.
It's also, yeah, it's like a suction cup type thing.
It looks like a hamburger bun.
Yeah, that's a good.
The top part of hamburger bun. That's what Ignacio says. I don't know. I thought that's very accurate.
No, because you draw from X, and you can draw sideways from the 3. Yeah, X equals 3 is the vertical. Yes, but look.
Eli, you done?
What was the boundary for?
I have an answer.
Oh
yeah, I'll take it right.
What was Free's boundary? What was the boundary?
This one's tricky. There's a reason why I say there's only probably 2 or 3 students can get it.
It did something weird, so I don't think it's. I solved that. What? Oh, yeah. Why not? I think it's 2 different. Wait, no, wait, this ends at. Oh, I've been doing it stupid this entire year. Because it stops at export.
Alright.
It's
Okay, I'm gonna go ahead and draw it. I will not translate the graph in any way, form, because that will ruin the idea of figure out things. So yeah, I know that's what Bennett did. When he told me, I was like, I already predict he did that because he liked to think outside the box, which is good. But I hear we rotating around x equal to 3. So where's the axis rotation? It's gonna be right here, right? Was that okay? Did you guys have this part?
Yeah.
Did you draw from the axis rotation to the boundary? How many lines do you see? 1, because the y-axis is not a boundary. Y-axis is just y-axis. Has nothing to do with boundary. Yes, so yes, this is a disk. Yes, Nizar. Because this is just empty space. You don't go to the y-axis because y-axis is y-axis. Has nothing to do with the bounded graph. I only care about the bounded graph. I only hit one bound. I'm not hitting the second bound. Second bound is the space. Yeah, that's a function. Let's stop there. It doesn't have any more. Okay, so is this dx or dy? Dy, good. Is a boundary from where to where? 0 to 3 or 0 to root 3? 0 to where? 0 to where? Root 3. Because it stopped right here. Right? It stopped right there. While integral stopped right there. Okay, so dy is it this washer? This, okay. So that must be r of y. So let's see who can come up with right r of y. Anybody can tell me?
Right what?
What is it?
Right what?
What is ry here? So you cannot have a negative 3.
Root 3 minus y squared.
Yes, Caden?
Y squared?
I don't know. What do you think? Okay. Anybody else think it's y squared? Okay, anybody else think different? Okay, Balin, what do you think?
Root 3 minus y squared.
Anybody else?
No, it's actually like I think, yeah, it might be something. I feel like it's has to have like a total space. So that's like translation.
But it's not total space.
The
The equation only
y squared minus 3. I don't like all this r and y stuff. Why can't we just stick with x?
Anybody else? Shh. Eli, what do you think?
Well, I don't want to say an answer because I don't really know at all.
I know. Nelly, what do you think?
I wrote down y squared.
3 minus y squared is correct.
Oh my gosh. Oh.
Alright, so why is it 3 minus y squared? I'm going to show you. You guys need to understand how the drawing works, right? So the drawing is based on, I'm interested about this part. But the function's given by this part. So therefore is the whole length, which is 3, which is the green, subtract the purple.
Wait, I did.
Green, subtract the purple. You did root 3.
Yeah,
It's supposed to be 3, not root 3, because you are looking at the distance. The distance, the whole thing is 3 units. So the r of y is equal to 3 minus, y is 3 minus. You take this, you subtract this, you get this. Does that make sense?
Yeah,
Okay. So for example, that's 3. The function's 1. You're going to get 2. 3 minus 1 equal to 2. It's from here to here. So this 3 minus a function. The function's y squared. It's not root x because you want to do it in terms of y. So you had to solve for y. So therefore 3 minus root y squared. Good job, Nelly. Even if you don't half asleep, you're still doing a good job. 0 to root 3 pi 3 minus y squared squared dy. You forgot. That's why I said there's a lot of things like people forget. Pi, forget square. It's like, I'm gonna take points off. I'm sorry.
Mr. J.
So I write down the 7 steps. Like, don't forget those things.
Is this like the So is this like an upside down bowl or like a sharp martini?
Let's look like a hamburger bun.
Okay, so
Yeah. Okay, so question 6. Rotating around x equal to 6.
oh wait a minute. My paper ran out. My translation thing is just the flipping the.
Yeah, but I'm not gonna look at your translation on. I want to you based on what graph without translation.
So we don't just
You evaluate, use a calculator, figure out, see if the right answer. If it's the right answer, you move on. If you can work out the math, you can work out the math if you have time. But I'd rather you figure out how to set up first because that's gonna be the most crucial part.
the only reason down here is there are threes. So when it equals 6, then the keep
Oh wait.
This one, what does this one look like?
It's like it's either empty space or down here. Yeah.
It's the same thing as before. Yeah.
That's that. Yeah, the funnel. Yeah.
This one look kind of like a bagel.
A big.
Okay, so wait, so we're
Huh?
looking for the volume?
Bagels.
Yeah. Okay, so you get rid of that.
Somebody's hungry.
So the x equals 3.
Words look like that.
Oh
It
yeah,
does,
that's
it look like
small one, which is subtracted. And that is 3. No.
They look pretty. There's another one. The x equals 3 stays. So
Huh?
function stays.
Mathematician. Not me. That's too smart.
It's like Newton or like that. Where dudes.
Oh, I don't know. I think they. I have a student. I never taught him washer or dust method. His name's Ethan. He played League of Legends a lot. So before I told him this washer, and I say I wanna find the volume of the shape, and he come up with the formula on his own without nobody taught him how to do it. He knew how to do an integral, and that's the only thing he knew. And he's like, wait, let me come up with something. So he come up, and it was like a disk method. I was like, oh wow, that's surprising.
Is he like a genius?
He might be off the chart, very very smart because he reading the math book I don't understand. Like he reading like a book like Axioms, like it's very very out there, like very old math. It's not even a contemporary math. It's like from 1200s, like Babylonians, and he read it for fun, for casual reading. So he might be one of the top student, like most smart student, have a bad grade. Like he has a bad grade. Like he has like an F in my class. But he also got a 4 in AP exam without even trying, just playing League the whole time. I had to throw his phone out like 10 times.
Like it's so infinite.
Oh my god.
One game.
Yeah, League of Legends mobile one.
The wild rift.
What? Is that Wild Rift? Easy?
Last I'm not gonna name drop.
Homer?
Oh my god. I mean, on the edge, bro. I
Like,
think I know.
give me a couple hours.
Let me learn this first.
Because it's like instead of 3 and then you want to like translate it.
Would the value still be 0 with 3?
Gabby, what are you doing with the phone? Give it a try. The problem that you gotta try. You gotta try. Connor, give it a try. Come on.
No, it's minus.
How do you find big R? I know, I can figure out big R.
No, but I called him out. I was like,
Big R. Little R.
this is like Mr. Bean, wonderful world. He's like,
Huh? There's only one in the room.
It's 6 minus y squared minus 3 minus y squared to the square.
I think that's kind of complex. Okay, so let's try it. Shh. Did you guys try it? Because I really need you guys to try and fail at something. Fail first, then succeed later. What?
It ain't working, bro. I sent you looking at it for like 5 minutes. Not even 5 cents, bro.
Fail first.
Yeah, that's y
Don't worry about that.
Failing for a while.
You've been failing for a while.
Yes.
Then you are better progression than a lot of people are. But did you draw that so far, Jesus? Okay, good. Shh.
Yeah, axis of rotation is.
You already
So what we're gonna do, we're gonna draw lines to the boundaries. So how many boundaries did you see? 2. So first one's gonna go from here to here. And stop right there.
What did I just do?
Second one, it's gonna go from here to here. Okay, so there was 2 lines. Now, what is we decide dx or dy? Dy, good. Is it a disc or washer? Washer. The boundary is from where to where? 0 to 3? Root 3. There we go. Okay, 0 to root 3 because it's going from here to here, not 0 to. Because we integrate like this, and we stop exactly at this point. This point is at root 3. So hopefully you have this part. Connor, do you have this part? Connor, come back to Earth. Come back from North Korea. Alright, shh. We have RY. We have RY here because this is a washer with 2 different type of radius. So, Fiona, what can you tell me about big R, small r here? Little r. 3. Uno, dos, tres. Look, I know Spanish. Yes.
Oh my god, it's 3. Oh my god. How is that just 3?
Because they stop right here. And in order to figure out where they stop, I plug in 3 into this function. So I know my output stop by 3. So 0 to 3. 0 to 3. Okay, what is... Yeah, that's the height of the... What it
So is the little r just the distance from the axis to where?
to the first boundary. The inner boundary. So that's the way you carve out the bagel, the middle part, the hollow part of bagel.
The
Can
bigger
you repeat how you got the 3?
Huh?
Can you repeat how you got the 3?
How do I get what?
3. It's just
3, it just count. 1,
Okay, got it.
2, 3, because it's always 3. Doesn't matter how I draw it. Doesn't matter what I draw here. It's always exactly 3 units because that's the first boundary.
Got it.
Okay, how about big RY? Kaden?
6 minus y squared.
6 minus y squared is good job.
That's what I got.
You over the little r.
Can you explain why 6 minus? Because it's 6 to here minus 1 squared. It's the whole thing minus 5. Just like here.
Yeah.
3 minus 5. Can you explain why 6 minus 5?
Because, okay, so the whole thing is 6, right? Shh. Remember, we told you the function of y squared, x equal to y squared, is from the y-axis to the function. So you cannot just say put y squared because y squared doesn't make sense. Because you wanted a purple line. We want this purple line from here to here. Guess what? We need to figure out the whole thing first. The whole thing is 6. Or 6 minus y squared is going to give me the purple. Because if I take the whole thing, take away the function, I'm going to get an axis rotation to the functions.
Oh, how is that? It's just like a little.
How is from
Yeah, it's just like a ruler.
One thing is 15, you can subtract.
Exactly.
How is it from 6 to 3? How do you put r little?
Can you explain to him?
Mystery, throw this out the window. It's already broken.
He's
My
playing
mom
Brawl
keeps killing me.
Who's playing Brawl Stars?
Brandon.
First black arrow.
I'm driving flat.
Three and it's always three. Never, when it's spinning, it's never happening.
Keep playing
It's always three. That line right there isn't gonna change. It's always three.
Okay, I'm rotating.
So I'm gonna see.
A new one. Y equal to y equal to 6. Y equal to 6. Rotating around y equal to 6.
What's your name right here? Face my proper.
We're gonna do one more after this.
Okay. And no one.
We need to make sure everybody got it. Rotating around y equal to 6. It's a horizontal line, by the way. It's rotating around that horizontal line. So is that dx or dy? Are they Biscuit washer? Are they
Why did you do that?
boundaries?
Alright, buddy.
I tried. I'm curious about any other way.
Around the Y? The Y to the long one? Do it.
It didn't look like Santa.
Oh no.
Now look at the fact that the many dimensions of the weird right now. So it's going to be You forgot the dimension of time.
What is going on?
Yeah, I think you just have to go down. That's right. Liam, yeah. So it's actually going to be a watching. It's watching, right? Did you do 1 minus or 3 minus 1 squared?
Nearly done? Jacob Bennett's done?
Yeah, it is.
No, wait a minute.
Yeah.
Batteries? Yeah, zero batteries. Yeah.
Because Y equals 6.
Why is it the X again?
It's a Y. So we're not.
McKenna, what did you do?
The longer
It's
line-
not this.
Nope. Wait, yeah. Yeah. Veronica 3 minus Veronica 1. Oh my god.
Why are you guys talking for 3 hours?
The reason it's X equals 3 is because that's given in the equation. Y equals 0. So
So,
Coach blame you guys?
well, kids anybody. They make a mistake.
It's not always.
It's like, we have a big picture, and it's
only worth 30.
It's like a fifth game that this happens. And we're just like we're shooting to each other. We have all our tests.
Are you guys both starting?
Yeah.
So how many pitch are there?
One of them just went on.
So
So we go to the trainers after school.
Oh, like I think Orbex.
All right, so shh.
Little Orbex. 6 minus.
D X or Y?
Wait, yeah. And big.
DX. So everything should be in terms of X, okay?
Don't tell me big.
0 to 3, is that okay? And the washer, is that okay? R of Y and small r of Y. What's the big R of Y?
Orbex.
Oh, RX, sorry, you're right. R of X, what's R of X?
Root X is 6.
No, 6. What's small R of X?
6 minus root X.
6 minus what?
Root X.
Root X, good. So integration from 0 to 3 pi 6 squared minus 6 minus square root x squared dx.
Oh my god. Dude. I feel bad for anything. This is the max amount of that. I'm never gonna have to do that.
Yeah, there will be one question to scare him about. If it's a
Yeah, it's like this.
they will ask you cross section which is gonna be Monday. Yeah, but alpha is rotation is fair game, but it's not all the time. Usually it's rotating around x and y. They will sometimes they will say rotate y equal to 2. But oftentimes they will ask the second part, which is cross section. Cross section is not about rotation.
This way the long
It's slightly different, but that will be very easy to explain on Monday.
Why is
Yes, shh, yes.
I don't understand why it's the washer.
Because there's 2 lines, it had 2 boundaries. One is the square root x graph, one is the x-axis, because they both are the bounded graph.
Oh wait, do we have? Is one of
So
the?
are we going whenever we draw the boundary?
Oh no, we cannot.
you scroll on TikTok?
What is the line? What was the line? What was the line? Never mind.
Okay. Alright, I feel like your brain is twice as big than before, so
I feel really smart.
you can practice homework.
You just upgrade.
Alright. The second picture, start with that one first because that one has answers. That one has answer on the second page. Now the first picture is the FRQ, what a question, or they will show up on FRQ. So there was 3 questions. So you got a lot of homework to do this weekend. And there was a K value, you had to figure out a K, so a little bit harder. But the second picture is better because it asks you to set up, and they will give you answer. Set up first, don't evaluate it. Okay?
Why does R big R?
Because it's linked from here to here. Because always this.
But when it's
Yes, so it's from the axis rotation to x-axis.
Okay, so one's from the rotation to the function, one's from the rotation to the